Hello there, welcome to CXC Math TV. Today we will be looking at relations and functions. So the first thing is, what is a relation? A relation is defined as a set of ordered pairs that obey a particular rule. Example, look at this ordered pair. -2, -1 as one ordered pair, -1, 2 as another, 0, 5, 1, 8, 2, 11. Now, the first set of elements of the ordered pair is called the domain, and they're usually going to be represented by the letter x on graphs. So we call them x values or x coordinates. So we can write down that the domain in this case is -2, -1, 0, 1, 2. The second set of elements, these are usually known as the range, and they're represented by y values. Alright, or we generally call them y coordinates. So we can write the range is -1, 2, 5, 8, 11. Now, in this example above, the rule which governs the relation is x is mapped to 3x plus 5, which means that x is mapped onto 3x plus 5. Now, remember what we said, we said that a relation is a mapping that obeys a particular rule. All we're saying is that the rule that maps x to y is 3x plus 5. Alright, so the relation can be shown on what is known as a mapping diagram. So when x is equal to -2, y is going to be, it's 3x plus 5. So where x is, we put -2. 3 times -2 plus 5, that gives us -1. When x is -1, 3 times -1 plus 5, that is 2. When x is 0, replace x with 0. 3 times 0 plus 5, that is 5. When x is 1, 3 times 1 plus 5, that is 8. When x is 2, 3 times 2 plus 5, that is 11. So notice that -2 maps to -1. -1 maps to 2, 0 maps to 5, 1 maps to 8, and 2 maps to 11. That is the mapping diagram, the x mapping to its corresponding y value. And that is known as a mapping diagram. Wow! Now, in the same way, a relation can be put on a graph. So the relation rule is y equals 3x plus 5. We already have all the x and y values, so we just need to plot the points. When x is 2, the y value is -1. When x is -1, the y value is 2. When x is 0, the y value is 5. When x is 1, the y value is 8. When x is 2, the y value is 11. Then, of course, we can draw the line of best fit passing through all the points, and that is our relation, y equal to 3x plus 5. Now, there are three types of relations. The first one is known as one-to-one relations. The second one is known as many-to-one relations. And the third one is known as one-to-many relation. Now, you might see in a different color, is a function, is not a function. So that's the next thing that we're going to talk about. What is a function? Now, a function is defined as a relation in which each element in the domain is mapped onto only one and one element in the range. Alright? That's a function. Just remember the definition for now. Alright? So just store that for now, and you're going to see how we're going to apply it to relations. So starting with one-to-one relation, which we know is a function. Let's go back to the one-to-one relation that we had. -2, -1, -1, 2, 0, 5, 1, 8, 2, 11. In this relation, x being mapped to 3x plus 5, we realize that each element in the domain was mapped to only one element in the range. For every one x value, there is one corresponding y value. This linear relation is known as one-to-one, and it is a function. And why is it a function? Because each element in the domain is only being mapped to one element in the range. In other words, it is a function since each x value only mapped to one y value. That is why it is a function. Since each x value mapped to one y value, it is a function. All right. Now, this was how it looked on a graph. Just to show again, that is why it is a function. Now, the next one to talk about is many to one. Many to one relation, which we say is a function. So consider the quadratic relation x being mapped to x squared. The arrow means mapped. Or some people might write it as y equal x squared. Or some might say f of x equal x squared. The mapping diagram for the domain x is such that x is between -2 and 2. So we only consider the domain when the x values are between -2 and 2. So when x is -2, y is -2 squared, which is 4. When x is -1, y is -1 squared, which is 1. When x is 0, the y value is 0. When x is 1, y is 1 squared, which is 1. When x is 2, the y value is 2 squared, which is 4. Alright. Now once we get our x and y values, we have our ordered pairs. And so we can put it on the mapping diagram as being displayed on the screen. So ordered pairs are -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. But look on the mapping diagram. The -2 and 2, those two x values map to the y value of 4. 1 and -1, those map to the y value of 1 that we put with red arrow, and 0 maps to 0. Now it is a function because every x value mapped to only one y value. I know you're probably saying, but you have these two different x value mapping to one y value. Yes, that's okay. That's just a many to one relation. Many to one relation. Alright? Many, but still mapping only to one. Alright? One y value. That's the key thing. So each x value only maps to one y value, and so that is why it is still a function. Wow! This is just how the graph would look. Alright, just a nice little curve when it's a many to one relation. Alright, now in this case, the quadratic relation above, the two different elements in the domain map to one element in the range. But since each element is mapped onto only one element in the range, thus the many to one, it is a function. Sometimes you might see people write it as f of x being x squared, or some might say y equal x squared. No problem with that at all. Alright, the next one is one to many relation. Now this one is not a function. Now consider the relation x being mapped to plus or minus the square root of x. For the domain when x is between 0 and 4. But we're only going to look at the numbers like 0, 1, and 4. Alright, because we can't use the other numbers because when you square root those, you're going to get some decimal. Let's look at 0, 1, and 4. So when x is 0, the y value is square root of 0 is 0. When x is 1, the y value is the square root of 1 is plus or minus 1. When x is 4, the y value is plus or minus 2. So notice now in the domain, if we were to put up the mapping diagram on the screen, you notice that 0 maps to 0, that's okay. But then you notice that the x value 1 maps to two y values. What did we say is the definition of function? Each x value should map to only one y value. Each x value should map to one and only one element in the range. So this is therefore not a function. Not a function since each x value does not map to only one y value. Alright, so that's why it's not a function. Wow! Alright, and if we were to display it on a curve right here, this is how the relation would look. Alright, just to display it on a curve. Alright, nice. Alright, now the next thing to talk about is what is known as a vertical line test. So a vertical line test is used to determine if a relation is a function. One point of intersection would mean that it is a function, and more than one point of intersection would mean that it is not a function. For example, remember the first relation, y equal 3x plus 5? This is a graph displayed right here. If we were to use a vertical line on that graph, you notice that the vertical line only detects one point of intersection with the line y equal 3x plus 5. And so therefore it is a function. If you were to look at the curve y equal x squared, displayed by the picture again, and then if we're to use a vertical line, it only detects one point of intersection, and so therefore it is a function. And if you were to look at y equal to plus or minus the square root of x, look at this now. The vertical line detects more than one point of intersection. It is detecting 2 points of intersection right there. Look at those 2 yellow points. So that one is not a function. All right, that one is actually the one-to-many relation, which is not a function. All right, nice. So now we're going to do some questions and we're going to answer these. All right, so let's answer these questions.
All right. All right, so pause the video and attempt this question. It says, which of the following is true about functions? Each element in the domain is mapped. Each element in the range is mapped. Each element in the domain is mapped once. Each element in the range is mapped once. Which of the following is true about functions? Pause the video and attempt. Well, first thing we said was a function. What's a function? A function says each element in the domain must map. So this is a definition of function. Each element in the domain must map, and it must do what? It must map to only one element in the range. And then it's going to be a function. So let's see which of these characteristics satisfy that definition. So first thing, each element in the domain must map. So each element in the domain must map, so one is true. Now each element in the range is mapped to. That's not necessarily true, because we can construct a function where nothing is mapped to a y value, but it is still a function. So this is the domain x, this is our range y. Look at this. The domain, let's say the domain is A, B, C, and the range is 1, 2, 3, 4. All right. And as we can see right here, maybe A mapped to 1, B mapped to 2, and C mapped to 3. That's a function. That is a function, but 4 is not mapped. So 2 is definitely out. It says each element in the domain is mapped once. Now that must be true. Number 3, each element in the domain must be mapped once. So 1 and 3, and so therefore it is going to be option C. Nice. All right, question 2 says, which of the following mapping diagram represents a function? So from the previous question, we said a function is where each element in the domain map, each element in the domain map, right? So pause the video and attempt this question using that definition. All right, in doing this question, realize what happened. Well, clearly we realize that this one is out because realize element D is not mapped. So element D is not mapped. So that can't be a function. Let's look at option B. Now, as we can see, element A does what? Element A is mapping twice. Element A mapped twice, so that is clearly not a function. So in this case, option C is the answer. All right? Option C is the answer because each element in the domain map and map to only one element in the range. Wow! So option C would be the answer. All right. Now this question, now it says, which of the following ordered pairs represent a function? So now we need to use the definition to look at which ordered pairs are function. Pause the video and attempt. All right. So first thing again, we know that each element in the domain must map and map to only one element in the range. Now look at option A. Option A, Option A is out because we realize that if we were to construct like a mapping diagram, we see that element 1 is mapping to two different y values. We see it map to 2 and 3. It's mapping to 2 and it's mapping to 3, right? So option A is out. All right, let's look at option B. Option B, as we can see, 1 maps to -2, 2 maps to -2, 3 maps to 4, and 4 maps to -5. That is looking good, right? This is looking extremely good. So option B, as we can see, this question is looking extremely good. Option B is looking good because if you were to construct a mapping diagram for option B, so we're saying option B is the answer, right? Look at it. X, Y. We're saying that element 1 is mapped to -2. And then we see that element 2 is also mapped to a y value of -2. Then we see that element 3 is mapped to a y value of 4. And then element 4 in the x is mapped to a y value of -5. That's perfectly fine. All right? Lovely. Now, as we can see, C and D are out because look at this. Element 5 is mapping to 0 and 4, and element 3 is mapping to 6 and 4. And so clearly, A, C, and D are out. So option B would be the answer. All right, now this question right here, it says, which of the following graph does not represent a function? Pause the video and attempt. All right, so first thing is, in order to determine if it's a function, we do what? We do a vertical line test. So doing a vertical line test, right, as we can see, we're moving this vertical line. Let's do our vertical line test. We're going to move this horizontal line. And as we can see, it's only going to intersect the function at one point. So A is a function. All right, so option A, it is a function. Let's look at option B. Carry over the vertical line. Still only intersects the horizontal. The vertical line still only intersects the function at one point at any given time. So that's also a function. Let's move over to option C. Going over to option C. Look at that. Doing the vertical line test, as we can see, it's intersecting at 2 points. So this is what? Not a function. Not a function. This is just a relation. All right, so that would be option C. So that's the importance of remembering the vertical line test to determine if a graph is a function. Wow! Using the vertical line test. All right, now sometimes it can be given the equation now and asked to determine which is not a function. So which is not a function? All right, so once you see square root, this would be the one that's not a function because we cannot square root negative values. We cannot square root negative values or... So option B is the answer because we have the square root. Now, how do we know it's option B? Option B, when you square root a number, for example, when you square root 9, right? When you square root 9, let's say x is 9. When you square root 9, you get two answers. That would tell us, so let's write it out. When x is equal to 9, then y would be the square root of 9 minus 1. That would be giving us plus or minus 3. When you square root a number, you get plus or minus. In that case, we're getting two y values. We'd be getting y equal to 3 minus 1, which is 2. Or we'd be getting y equal to minus 3 minus 1, which is minus 4. In that case, we're saying that 9, 2 is a point and 9 minus 4 is a point. So when x is 9, you're going to get two y values. And so that cannot be a function. Nice.